everybody. Gotten a lot of questions on today's lab, which I love. So I thought I'd jump on quick and try to answer some of those without having to send like a bunch of individual emails. So when you're going through, first thing, you have your worksheet. The data for this is on that student data tab. And there's one thing on here I want to point out. This negligible just means that it's pretty much zero. So when you're using the final mass of your wood splint, know that it went from 0.30 grams to pretty much zero. And you can use that number zero in your calculations. So question one is pretty straightforward. You're just figuring out how much when you burn the item underneath the water, what is the change of the water in the can? So that's just a simple subtraction problem. But then when you get to number two, we get a little bit confused, I think. This problem, you're going to have to use the specific heat of water to calculate how much energy is produced when that change happens. So if you remember from last week, the formula for specific heat is going to be the Q, or the energy, is equal to the mass of the thing you're heating. So the mass of the water in each can is 50. So the mass is 50 multiplied by the specific heat. And since we're heating up water, it will be the specific heat of water, which is 4.186. And then times your change in temperature, or your delta T. So you're going to go through and calculate what is the energy when you burned the charcoal underneath the water, and then what is the energy when you burn the wood splint under the water. So those are going to be two different numbers that you're going to get there. Number three, determine how much fuel was burned. This is subtracting your final mass from your initial mass. So you're going to take your initial mass. So charcoal would be this number minus this one. And then for the wood splint, you got 0.3 and the whole thing burns up. So 0.3 minus 0, it's going to be a difference of 0.3. And once you have that number, you can answer number 4, which is asking you to calculate how many joules per gram are created when you burn these things. So you're going to use the energy from number 2, and you're going to divide it by the change in mass from number 3. And then 5 is asking you, if you have these two materials, which one is going to be the higher density, or which one is going to produce more energy per gram. So hopefully that clears up the questions that you guys had. If not, send more questions my way. I love to answer them. Good to hear from you guys.